All right, homework 3.2 is on transformations, and these should be fairly straightforward. I'm going to go through a couple of them with you where I think you might run into trouble. The first one I'm going to do with you is C, and the first thing we want to do is decide what parent function this is. You should be good at that from our first unit, and also what transformations happen. So this is a square root parent function, and you should know that the square root of x looks like this. It's increasing but concave down. The transformations that happen is there's a horizontal shift. Remember, those are backwards from what you think it might be. This would be left by 9. And there's a vertical translation up by 4. And so this vertex point should be at -9, +4. So those are the translations, left by 9, up by 4. This is a vertical stretch by a factor of 2, and that means that all the y values are going to be 2 times as high as they normally would be from the square root function. Let's look at how that works. Once we've done our shift and shifted our vertex, we're pretending like this is 0, 0, and we're going to do square roots from here. So the first number that you can easily do a square root of is 0. Square root of 0 is 0. Multiplying by that by 2 doesn't do anything. 2 times 0 is still 0. When we go over by 1, the square root of 1 is 1, and 2 times 1 would be 2. So the parent function, square root of 1, would be 1, and that would be right here. But because it got vertically stretched, square root of 1 was 1, and that gets multiplied by 2, giving us a point at 2. We can't do the square root of 2 easily. It is 1.4 something, but because it doesn't come out to be a whole number, we skip it until we get to the next number we can easily do the square root of, and that's at 4. When x is 1, 2, 3, 4 away from the vertex, we always go back to the vertex. 1, 2, 3, 4. The square root of 4 says what times what is 4, and the answer is 2. Because the square root of 4 is 2, we need to multiply that by 2. 2 times 2 is 1, 2, 3, 4. And again, remember what's happening here is all of the y values are getting multiplied by 2 after we do the square root. So we do the square root, and we multiply by 2. The next number we can do the square root of easily is 9. When we go 9 over from the vertex, the square root of 9 is 3. So what times what gives you 9? The answer is 3, and we need to remember that that's being multiplied by 2. So 3 times 2 is 6, and that multiplies and gives us a nice concave down square root. I'm going to do another one of these just to make sure we're in the right place here. This is a cubic parent function. The cubic parent function looks like this. It has an inflection point at 0, 0, and that's going to be shifted 5 to the left and 7 down. So we have an inflection point down here at -5, -7. Similarly, remember the horizontal translation is backwards from what you might think. And we're going to use our trick again. We're going to go here and we're going to do cubes from the vertex as if this was 0, 0. Going to the right by 1, 1 times 1 times 1, which is 1 cubed. 1 cubed is 1, and half of 1 is 1/2. When we go 2 to the right, we're doing half of 2 cubed. 2 times 2 times 2 is 8. Half of 8 is 4. So what that tells us is when we go 2 to the right would be 2 cubed is 8, and half of 8 is 1, 2, 3, 4. So you'll notice it didn't go up by 8, it only went up by 4. Going to the left, we're doing half of -1 cubed. -1 times -1 times -1 is a negative, would be -1, and half of -1 is -1. It's very important to make sure you at least check the first point and possibly more if they fit. We can almost fit the third one. I wonder if we can here. 1, 2, 3. When we go 3 over, 3 times 3 times 3 is 27, and half of 27 is 13.5. If we try to put that on the graph, it will barely fit 10, 11, 12, 13.5. So that'll fit as well. I'll do one of these with you guys. I think I'll do B on the using the vocabulary ones. So B, we see an absolute value parent function. We need to make sure we go in the right order. It's getting translated to the right first, and we know that because that's where the x is. That's the first thing that happens. Then it's going to get multiplied by -3. We'll talk about what that does, and shifted down by 4. So here's what a good vocabulary answer should be. On B, let me zoom out so you guys can see more of this. On B, we would say the absolute value parent function is translated, or you could say shifted, 3 units to the right. Then the next thing is getting multiplied by -3. Remember, multiplying by a negative reflects over the x-axis. Multiplying by a number multiplies all the y values, and because the absolute value of -3 is above 1, it gets vertically stretched by a factor of 3. If the number had been if the absolute value had been less than 1, we would say it was vertically compressed. And finally, it gets shifted or translated 4 units down. Okay, do 1 on the back, and then we will stop. I'm going to call this A, this quadratic one. We see a parabola, we see it's a quadratic parent function, and so we need to start with y equals, or f of x equals. And I see that the vertex was shifted 2 units right and 3 units up. 2 units to the right is, of course, going to be backwards from what we would think it would be. So it's x minus 2 squared. Shifting up by 3, this is 2 units right and 3 units up. That takes care of our translation. Now we have to be very careful to get this number right. And the easiest way to do it on all these functions is to start at the vertex and go over by 1. When you go over by 1, this would be 1 squared because it's a quadratic. 1 times 1 would be 1, and that is not where this point is. And so it must be getting, in this case, compressed because it's lower down than it would be. So it has to be multiplied by a number that's less than 1. Maybe it looks to me like maybe it's 1/3 or 1/4, but it's hard to tell exactly because it's not an exact point. I like going to the next time we have an exact point and going from there. When x is 2 away from the vertex, 2 squared would be 1, 2, 3, 4. And now we can tell what it needs to be multiplied by. Instead of being at 4, it's only at 1. So what number do we multiply 4 by to get to 1? That number needed to be 1/4. That way when we do 2 squared, it would be 4, and 1/4 of 4 would give us 1. That makes it match up. So that's how we find the stretch or compress factor. You also want to be on the lookout for reflections. So one of these got reflected across the x-axis, one got reflected across the y-axis. Hopefully this helps.